Welcome back, folks. So we have one more example to talk about with elimination, and this is one of those kind of bring all the ideas together type of questions, right? So I want to solve this one, and again, you could use elimination, you could use substitution, but in this example, in this video, I want to use elimination. Now, as you can see, the first equation is 4x plus 3y, and on the second equation, we have 9x minus 4y. Just like before, in both of the previous examples, I can't just combine them right away. Whether I add or subtract, I'm not going to eliminate x, I'm not going to eliminate y. I think you can see that here. The question is, which one should I change? Well, let's see. If I multiply this one, I would have to multiply it by some kind of weird fraction or decimal if I wanted to eliminate y, say. For example, if I want to eliminate y, I would need to get the 3 to be, well, right now it's 3y. And if the other one's negative 4y, I would want to get this 3y into also a negative 4y or maybe a positive 4y. Unfortunately, there's no whole number where 3 times that number is equal to 4. So it makes our lives a little bit difficult. You could multiply it by a fraction, but the whole point of this elimination method is kind of to give you some kind of clever tool where you don't have to deal with those fractions. Or at least you have to deal with them as rarely as possible. So here's what we can do though, is there's no reason that we couldn't just play around with both of them. And so let's pretend we want to eliminate y. If I want to eliminate y, and I'll scooch over here. And there's no reason you couldn't choose x as well, by the way. I'm just choosing y. Let's say we want to eliminate y. Well, let's see. I'm going to have to multiply equation 1 times something, and I'm also going to have to multiply equation 2 times something. Let's see. If I go times 2, well, sorry. For right now, it's at 3y. If I multiply it by 2, I'll get to 6. And if I multiply it by 3, I'll eventually get to 9. By 4, I'll go to 12. And if I kept going, be 15 or 18 and so on. If I multiply the second equation by something, well, again, we're starting off at 4y. Well, I guess negative 4y. If I multiply it by 2, we'll be at negative 8y. By 3, we'll have negative 12y. If I do it again, we'll have negative 16 and negative 20. And by the way, this would also get to 20 eventually. Oh, sorry, that would be 21. 21, and 24, and so on, and then negative 24. So we can see here actually that eventually, if you multiply by the correct thing, you will eventually be able to cancel out y's. You have two options here. Actually, you have a lot of options, but one option is to multiply and turn both of those y's into 12y and negative 12y. Or you get them into 24y and negative 24y. So which one should you pick? Probably 12 and negative 12 because the number is going to be smaller and easier to work with. So let's do that. Okay, so if I want to get 12y, I'm going to take equation 1, and I'm going to go times, let's see, to get 3 to 12, I need to go times 4. And I'm going to take equation 2, and I'm going to multiply it by 3. So what does this look like now? Well, now the system's going to look like this. 4 times 4 is 16. 3 times 4 is 12. 10 times 4 is 40, 40. The second equation, let's see, 9 times 3 is 27. Negative 4 times 3 is negative 12. And 1 times 3 is 3. Now, be careful here. Okay, so I have 12y and negative 12y, so if I want to combine these, at least as is, I'm going to add them. So now I will add the left side to that and the right side to that, and let's see what happens. So let's see, 16 plus 27 is going to be 43. 12 and negative 12 when I add them will be 0. 40 plus 3 is 43. And look at that, we could divide by 43. Oops. And get, x is equal to 1. Wrap this up by plugging this in. what's nice about this is that you don't have to plug it into these complicated equations that you made bigger. Right? Remember, this equation is still just equation 1. You just change both sides. You just change the way it looks. And so you can still just plug it into the original equation 1, say, and I'll get 4 times 1 plus 3y, oops, sorry, got distracted there, is equal to 10. We solve this, we will get y is equal to 2. So if the two variables, let's say you want to eliminate one of the variables. If one is a nice easy multiple of the other, like in example A, then you only have to change one of the equations, and you'll be lucky if that's the case. But in the case that they are not, well, eventually you're just going to have to multiply both of them. And the easiest way to kind of figure out which way to multiply is you could always multiply by the opposite coefficient. Here's what I mean by that. We actually did that here. 3 and 4 will have a common multiple of 3 times 4. And that's where we got 12. So you could always do that. There might be a smaller number before that, but this will always work. Okay, so hopefully this helped. And I'll see you in the next video, which I'm actually not sure what it is yet, but I'll see you later. Hopefully this helped. Let me know if there's questions.